Hello and welcome back. In today's video, we're going to be processing tin ore into tin metal and exploring its fantastic properties. Tin metal's name is used in many things, even though they don't contain tin mostly. Tin foil, which is actually aluminum, tin roofs, which is actually steel, and tin cans, which is a steel, even though some of them, like peach cans, have an electroplating of tin inside of it to protect the can from its acidity. Tin also has some other unique properties. But let's first get some tin out of the ore and then explore those properties. Tin ore, also known as cassiterite, is a tin oxide ore, so it's pretty easy to liberate. All we need to do is remove that oxide at high temperatures and we'll be left with our tin metals. As I said before, the tin is in the oxide form and it needs to be removed for it to form metal. So to do that, we need to reduce it down. The easiest method for reducing it is just by using regular burnt wood carbon. The carbon will react with the oxide, forming carbon dioxide at high temperatures. The carbon dioxide will go away. The rest of the carbon will protect the oxide from attacking the tin again, and we'll be left with our tin metal. And there we have it, our tin powder. As I said before, the tin is in the oxide form and needs to be reduced down in the tin metal. We have a few options that we can use to remove that oxide, but the easiest and simplest one is the one that's been used for centuries. By taking carbon in the form of wood charcoal and powdering it down. We can then take that carbon and mix it with the cassiterite ore. That carbon will bond to the oxide will form carbon dioxide, and that will be gone off a gas. And the carbon will also shield it from oxidizing further while it's in the crucible. I brought over my anvil, so now we can break down the cassiterite with a hammer. First I'm going to throw it in a little bag so we don't get the pieces thrown everywhere. I got my skillet and threw a piece of paper on it. Let's take the crushed rock and see how much it weighs. It looks like we have 168 grams. Let's add this to the carbon and then load it up in the crucible. Carbon's some messy stuff. We're now outside. Let's turn the furnace on. And 2000 degrees is way hotter than we need. So let's reset that down to about 1000 degrees. That's much higher than we need to melt tin. Drop the crucible in. And come back when we're up to temp. Okay, we've been up to temp, and I decided to increase it by about 1000 degrees so it went a bit quicker. Let's take the crucible out and transfer it over. Okay, we're all cooled off, and I threw some water in there. Let's dump it in and see if we got anything. And it looks like we got some nice hunks. They need to be cleaned up a little bit, but it'll work. Probably some stuff stuck at the bottom still. Let's go wash this and get rid of all the carbon. Here's the tin that I removed so far. Let's drop it on the scale and see how much we have. Looks like we have about 26 grams. And we have a lot more in here. You can see some specks that have formed that are way too small for me to just spend hours picking through here. So I'll add in a clip at the end of one of the next episodes of me refiring this and melting it down into a bead and giving that weight, plus this weight. The tin ore that didn't react the first time. Let's get our total weight now. And it looks like we're up to 38.20. Now let's make some permanent bronze with our tin. Now that we have tin, we can explore one of its very cool properties. Now, when tin melts, it forms crystals in it. If you take it and you can dissolve the acid, you can see the crystal structure. This twinning crystal structure makes it cry when it bends. This is called tin cry. Now, once it's all bent up, you can't hear the tin after crying after. But if you take a blowtorch and you just heat it up again, those crystals will go back to normal, and then you're able to do it again and again. Bronze is a quite simple alloy consisting of 1/8 tin and 7/8 copper. Let's throw it in the furnace and get it melting. The furnace is still hot from the previous melt, so it'll get up to 2000 pretty quickly. We're setting it to 2000 because that's above the melting point of copper. Let's throw our metals in and get melted. We've been up to temp for quite a while. Let's open it up and take a look. You can't see anything, but there's a nice hunk of metal down there. Let's pour it out and take a look. Here's our piece of bronze after taking it out of the furnace and letting it cool. I went and ground down the oxide on the backside, and it's a nice gold color. Now we're up to 5 elements. We've got our hydrogen, our carbon, our oxygen, our tin, and our copper. Now the interesting thing about tin is it's quite uncommon. Uranium ore is actually more common than the tin ore, the cassiterite. So it's kind of funny to think that in ancient times when they were able to find this and trade them enough to form an alloy known as bronze, which brought us into the Bronze Age.
Well, I don't know, but I've been told uranium ore's worth more than gold. I sold my cad, I bought me a Jeep, I got that bug and I can't sleep. Uranium fever has gone and got me down. Uranium fever is spreading all around.